Hello, my name is Kyle Olszewski, and I'll be presenting a novel approach to synthesize and edit beards and hair in real facial images. Our framework consists of a two-stage pipeline. In the first stage, a sparse set of guide strokes defining the local shape and color of the target hairstyle is used to synthesize an initial estimate of this hairstyle. In the second stage, this estimate is refined and composited into the target image. We train these networks using a set of guide strokes automatically extracted from facial hair images. These strokes are created by estimating a vector field defining the dominant local orientation of the depicted hairstyle and integrating this field at various points to create sparse individual strokes with the appropriate shape and color to describe the overall structure and appearance of the depicted hairstyle. As no large-scale data set of real facial hair images exists, we augment a small set of real facial hair images with a larger set of synthetic renderings of facial hair of a wide variety of shapes and colors. This allows us to tractably train our system with relatively few real facial hair images. When training our two-stage pipeline, we first train the initial synthesis network in isolation on the large-scale synthetic dataset. We then refine this network by training it end-to-end with the refinement network on the set of real facial hair images. As our image synthesis framework allows for any 2D color input, we extend our approach to allow for the creation of a fast initial estimate of the target hairstyle. We do so by training a separate set of networks to synthesize the target image from a color mask, defining the shape and average color of the synthesized region. We can then extract a vector field and the corresponding guide strokes from this initial estimate, which can then be edited by the user to allow for refinement of this estimate before performing the final image synthesis. Here we show an example of this initial synthesis performed in a live session. Given the specified color and shape of the user-provided mask, we quickly synthesize the overall target hairstyle as seen on the right, and extract strokes matching the structure and color of this result as seen on the left. Each time the user updates the shape of the masked region or specified color, we update the synthesized facial hair and strokes. Our pipeline allows for flexible user input that allows for easily synthesizing a variety of complex hairstyles. For example, the user can create or edit a vector field defining the overall structure of the desired hairstyle, from which a sparse set of guide strokes can be extracted, as is done with the training data. Similarly, the user can create or edit the color field that is sampled to determine the color of these guide strokes. Here we show an example of the user editing the structure of the synthesized hairstyle by editing the underlying vector field as visualized on the left. By locally editing this default vector field according to the direction and magnitude of the user-provided brush strokes, small changes to this field can be used to make corresponding changes to the guide strokes extracted from this field. With each brushing operation, these changes are used to update the guide strokes and the corresponding synthesis results as seen on the right. Given enough of these brush strokes, the user can change the overall structure of the synthesized hairstyle. Our system also enables the user to add, delete, and change the shape and color of individual guide strokes. Such edits often result in subtle changes in the synthesis results, but are effective in offering a high degree of local control. In order to support coherent transitions between the dense and sparse facial hair regions, we allow users to specify transparent strokes. As seen here, sampling the skin tone and adding semi-transparent guide strokes with this color results in smooth and natural transitions between the beard and underlying skin. We conducted a user study to measure the ease of use of our proposed system. Given the depicted reference hairstyle, users with no experience with our system were asked to create facial hair corresponding to that in the depicted image on a clean-shaven subject. Despite their lack of experience with our user interface or general technical artist training, subjects were able to quickly author the depicted hairstyles using the aforementioned tools provided by our framework. Their feedback indicated that they found these tools very useful in quickly and intuitively authoring a hairstyle matching that of the reference image. For more details, please consult the paper and supplementary document. Finally, we demonstrate that our system can be used to perform high-fidelity scalp hair manipulation as well. By refining our trained networks using a set of approximately 5,000 images of scalp hair with corresponding guide strokes, we are able to synthesize a wide variety of both female and male hairstyles as seen here. In addition, the same model can still be used to plausibly author a variety of facial hairstyles given the appropriate set of guide strokes, as seen in the last columns of rows 2 through 4.